Okay, so we'll continue solving. Let's go to part. So we'll continue solving from where we ended. So we managed to solve question 1 and 2. Now we go to 3 and 4. So let's see how we solve part 3 and 4. So continue. So part 3 looks pretty simple. So we have v, which is integrate x squared over, so we have x squared plus x minus 2 dx. So we just have to factorize the denominator first of all. So you remember this one looks the same as the one we had just previously. So we had x squared plus x minus 2. So factorizing, I mentioned that first you calculate the product, which is a by c. So a is a coefficient of ax. So this is what I'm talking about, is coming from here. So coefficient of x squared is a, so coefficient here is 1. The number in front is only 1, so I just say 1 multiplied by c. This number here you get with a sign, so negative 2. So negative 2 multiplied by 1 to be negative 2. So sum equals to b. B is here coefficient of x. So x coefficient is just 1. Okay, and you find factors. So factors are numbers which, when you multiply them, they give you the product, and when you add them or subtract them, they give you the sum. So we had earlier calculated negative 1 and 2. You can start with either negative 2 here or negative 1 this side. It's the same thing. So x squared, we substitute this now where there is b, so we are removing this guy here and substituting these factors. So substitute, this will be x, since you can't write negative 1x, no. Then plus 2x minus 2. So group, this is get 12 marks, guys, so just remember nicely, revise. So this is x, we factor out x here, so there will be x here minus 1. Then this side we have plus 2. Here it will be x minus 2 into 2 is 1. So you just have like this. Then this and this has to be the same inside the brackets. So you get what is outside, group them. You have x plus 2. Then these are the same, just say x minus 1. So this is our denominator. Okay, so first of all you factorize, so you have, we write this is x squared over x plus 2 x minus 1 dx. Okay, so now we know we have expressed it into linear functions. So now we decompose. So we just write this equation minus we remove the integration, we write it later on. So okay, so you have x plus 2 x minus 1. So we know the power of x is 1, so these are linear, meaning we only have constants. A, let's say x plus 2 plus b over x minus 1. Okay, so these are our values. We only have 2 on the denominator. So now next you multiply by this denominator, the whole of it, on the right and left. So if you multiply this, the whole fraction here, by this denominator, you only remain with x squared here. Then this side we have 2, so a is multiplying with this, it's the same, this multiplying by this. because this one is not complicated because you only have two. We only have two, so there's nothing to complicate life with. So how do we find these answers? I've showed in the earlier video. So you have a over x plus 2, you're multiplying it by x plus 2, x minus 1. So this and this will cancel. So you have a multiplied by this. So it will be a x minus 1 plus b. B same is b over x minus 1. So you're multiplying it by x plus 2, x minus 1. So this and this will cancel. So b will be x plus 2. So just swapping this multiplied by this multiplied by this. Okay. And this I just get the numerator. So now we have two functions. We have this and this. So we equate this equation equals to 0 and this equation equals to 0. Then solve. So we say x minus 1 equal to 0. What is the value of x? So we have x equal to 0, and it comes this side, it will be plus. So it will be x equals to 1. First part. Number 2, when we get this one, x plus 2 equal to 0. So we'll solve for x. So x equals to 0 minus 2. When this comes this side, it will be negative. So x equals to negative 2. So you have these values. Okay. So this one is simple. So I won't say like you cancel. Okay, let's just solve it nicely. So we say when x is equals to 1, so we substitute 1 where there is x in all these equations. So we have 1 squared. This is here. This part we are substituting. Okay, equal to. So we have a x is 1. So we have 1 minus 1 plus b 1 plus 2. Okay. So 1 squared is 1 multiplied by 1, which is 1. So this is 0. Then 1 plus 2, 3. So it will be 3b. Meaning over 3 over 3. This implies that b is equals to 1 over 3. Okay. So next we solve for when x equals to negative 2. So we say negative 2 squared equal to a negative 2 minus 1. So we are substituting here negative 2 and here also negative 2. Then b plus b negative 2 plus 2. So negative 2 squared, the same as negative 2 multiplied by negative 2. Answer is positive 4. So make sure you don't mess up the signs. Okay. Okay. Oh. What's happening? Okay. Okay. So let's have an issue with. Okay. So what's happening? Oh, so sorry about that. Okay, so this freezing, right? Has been on for a long time. Sorry about that. So okay, so we continue. So this is 4 equal to, this is negative 2 negative 1, so negative 3a plus negative 2, positive 2, that's 0, so we won't write it. Yeah, so yeah, this is just the same as plus 0. Okay, so we have 4 equal to negative 3a. So if you divide by negative 3, divide by negative 3, so you have a is equals to negative 4 over 3. So we are all doing this in order to make our integration simple. Okay, so now since we know the value of a and b, so we know, so x squared over x plus 2. So I'm just rewriting this equation here, this one, x minus 2, x minus 2. So replace the values of a and b accordingly. So a is negative 4 over 3, then 1 over, what was the value for a? A was at the value x plus 2, so x plus 2. So don't swap them. When you swap them, your answer will be wrong. Okay, so b and 1 over x minus 1. So b plus, what is the value for b? B is 1 over 3. Okay, so 1 over 3, 1 over x minus 1. Okay, so now we have separate equations instead of this joint. So that's the whole point of doing partial fraction decomposition. Now we integrate, since now we know that it's easy now to integrate because we have separate equations. So we have this integrating this and also integrating this. So we have negative 4 over 3, 1 over x plus 2 dx plus 1 over 3, 1 over x minus 1 dx. Okay, so we continue. This is the same as equal to, the constant can come out, 4 over 3, 1 over x plus 2 dx, and also plus 1 over 3, 1 over x minus 1 dx. Okay, so we know integrating a linear function, 1 over linear function is ln that function. So 1 over any linear function is ln of that function. So this is 4 over 3. This is ln this function. We all know that. So, and then plus, sorry, okay, this is a negative. Okay, there is a negative here. Okay, this is a negative. Sorry about that. Very important to follow the signs. Okay, then this 1 over this to be ln x minus 1. So add the plus c because we don't know the limits. So integral of this function dx is equals to this. So I think we can factor out 1 over 3. So this is same as 1 over 3. Okay, there will be negative 4 here. Let me write properly. Okay. Oops. PC is tired. Okay. Just wait a little bit. Okay, so okay. This here, so we write negative 4 ln x plus 2. Okay. Then here this one is outside plus ln. So x minus 1. Okay, like this. So plus c. So this is the integral x squared over x plus 2 x minus 2 dx. Okay, so let's go to part 4. Finish part 4. We still have time. Okay, so part 4, use the same formulas, same partial fractions. So part 4, integral x over x plus 1 dx. So we need to factorize this one to make this equation simple. We know this one is already linear, so let's try to factorize this one. So you have x squared minus 4. So we remember this from difference of two squares. This is same as x comma x minus this is 2 by 2. Remember this very well. Okay, so the way we used to solve it in grade 12, we have a negative here, we have a positive here. Then we get x here, we get 2 here, we get x here, we get 2 here. So these signs, they have to be different because we have a negative here. Negative multiplied by a positive, negative. So this is the same as this. So this, meaning you factorize completely. If you doubt, you can take it back, you can multiply. So you have x minus 2, x plus 2. So you can multiply x multiplied by everything, negative 2 multiplied by everything here. So you have x plus 2 minus 2, x plus 2. So this by this give you x squared plus 2x, this negative 2x, negative 4. So negative 2x minus 2x to be 0, so you have x squared minus 4. Okay, so we know that when you factorize this, it will give you x minus 2, x plus 2. Okay, so this equation is same as x over x plus 1, x plus 2, x minus 2 dx. Okay, so now it's simple, everything is linear, you just write ABC and solve for ABC. So let's just rewrite it here. We have x plus 1, x plus 2, x minus 2 dx. So this is equals to a over x plus 1 plus b over x plus 2 plus c over x minus 2. Okay, so no need to write an integration here since we are decomposing. Okay, so just remove this one a bit and this one. So we are decomposing this into individual components so that our integration becomes simpler. Okay, so let's continue. Now the job is just to find A, B, and C. So I've showed you multiple examples now. You multiply both sides by the denominator, this. So our denominator is this one. If you multiply this side, you only remain with x. I've showed you how to multiply. Then you have a over x plus 1. You are multiplying with x plus 1, x plus 2, x minus 2. So this and this will cancel. You are only remaining with these ones. Okay, that is A. For B, B is over x plus 2. So you're multiplying it by x plus 1, x plus 2, x minus 2. So plus 2, and this one will cancel. B will have this and this. Same applies to C. C is over x minus 2. So you're multiplying it by x plus 1, x plus 2, x minus 2. So this and this will cancel, meaning C will have this and this. Yeah. So write x is equals to a as what? X plus 2, x minus 2. Okay, plus b as what? X plus 1, x minus 2. Plus c as what? X plus 1, x plus 2. Okay, so we have all these values here. So next, we equate now these functions, these individual linear functions, equal to 0 each. X plus 1 equals to 0, x plus 2 equals to 0, x minus 2 equals to 0. So we have x plus 1 equal to 0, okay, x plus 2 equal to 0. We also have x minus 2 equal to 0. So now let's solve for x here. Like terms, x equals to 0 minus 1. So x equals to negative 1. Here we have x equals to 0 minus 2, and this goes this side to be negative. So x equals to negative 2. Here we have x equals to 0 plus, when negative 2 comes this way, it will be plus 2. So x equals to 2. So you have these values for x. So you can substitute now. You start with x equals to negative 1. You substitute everywhere here negative 1. Then you get the answer. But that will be a lot of writing. So the shortcut is this one, x plus 1. When x is x plus 1, the value of x is what? Negative 1. So let's look through this equation. Which one has x plus 1? This one here, x plus 1. This has x plus 1. So this will be 0. This also has x plus 1. This will also be 0. So we only remain with a and this x. So now we substitute now x equals to negative 1. So we'll have negative 1 here. We'll put negative 1 equal to a. Then where there is x, put negative 1 plus 2. Negative 1 minus 2. Okay. We have negative 1 equal to a. This is 1. And then this is negative 3. So we have negative 3. Okay, so negative 1 equals to negative 3a. Divided by negative 3. Divided by negative 3. So a equal to 1 over 3. Okay, so this is x plus 2. So we will check in your equation. Which one has x plus 2? This has x plus 2. This x plus 2. So this will be 0. Also x plus 2. This will also be 0. So meaning we are dealing with b only. Simple. Substitute x equals to negative 2. So you say negative 2 equal to, so we are remaining with b only here. So you have b. We can't write a and c because they will give us zeros. Negative 2 plus 1. Okay, then negative 2 minus 2. Okay, so negative 2 equal to, so you can say when x equals to negative 1, this one is when x equals to negative 2, for completeness sake. So it will be, this is negative 1, this is negative 4. So negative 2 equal to, this will be positive 4, so 4b. So over 4 over 4. B equal to, so 2 into 2, 1, 2 into 4, 2, so it will be negative 1 over 2. So this is the value for B. Then you also find for C when x is what now? X is this last one, x equals to 2. X equals to 2. So let's go back to our equation. For us to get x equals to 2, we use the x minus 2. So let's see which one has x minus 2. This one is 0. This one also has x minus 2 is 0. So we won't remain with the C. Then we substitute x equals to 2. So we'll have 2 equal to C. C is x plus 1, so 2 plus 1. Then x plus 2. Okay, so 2 plus 2. 2 plus 2. So this is 2 equal to, this is 3. C equals to 3 by 4. Okay, so which is 12. So you have 2 equals to 12C. So divide by 12 divided by 12. C equals to, this and this will cancel. 2 into 2, 1. 2 into 12, 6. 1 over 6. So now we have all the values. Now we substitute. So x over x plus 1, x plus 2, x minus 2. So here, be careful to substitute accordingly. So each one, A, if it was over plus 2, you write it the way it was in the original equation. So A was divided by what here? A was divided by x plus 1. So that's how we write. So A is the value for A, 1 over 3. So we write 1 over 3, 1 over x plus 1. Okay. Plus B. What's the value for B? Negative half. It's negative half. Then B, what was it? Is it 2 over 3, 2? Okay, x plus 2. So x plus 2, 1 over x plus 2. So it's 1 over x plus 2. Okay. Plus C, 1 over 6. Meaning 1 over x minus 2. Okay. So don't swap. Write the way you had written them here. So if B was this denominator, write it the way it was. Okay. So next, now that's when now we integrate. Since we know this is simple, we can integrate this, we can integrate this, we can integrate this. So we write now integrating x over x plus 1, x plus 2, x minus 2 dx is same as integrating everything here. Same as integrating, so you can put them in the bracket, everything. 1 over x plus 1. This will multiply by this negative half. 1 over x plus 2 plus 1 over 6. Okay, 1 over x minus 2. Everything dx. So this is the same as integrating individually. You are distributing. Integration is distributive. 1 over 3 dx minus half 1 over x plus 2 dx plus 1 over 6 1 over x minus 2 dx. Okay, so we can take out the constants outside. Okay, so 1 over 3 can come out. We have 1 over x plus 1 dx minus half will come out. 1 over x plus 2 dx plus 1 over 6 1 over x minus 2 dx. Okay, so you know this is 1 over 3. This is a linear function. 1 over linear function, integrating 1 over linear function is a ln of that function, x plus 1 minus half. This is ln, very simple, ln plus 1 over 6 ln x minus 2 plus c. We don't know the constant, so we add plus c. So now I write in full integration x plus 1 x minus 2 x plus 2 dx is equals to, so I can group these if I want, because I can take out 1 over half, yeah, or group these two, because I can take out 1 over 3, it's the same. So you can just say, let me take out 1 over 3, then here I'll remain with ln x plus 1. So I'm grouping this one and this one because they have a common constant or coefficient, sorry. So this will be just 1 plus 1 over 2, because 2 multiplied by 3 to be 6. Okay, ln x minus 2. Okay, so these are grouped, then minus this one, which is alone, 1 over 2 ln x plus 2 plus c. So if you don't want, you can just leave it here. Don't forget to add the c here, because we don't have a limit for this function. So this is your answer. Okay, so thank you for watching, guys. I'm sure you subscribe, invite your friends. Yeah, continue. You can ask questions where you're not clear. If you have doubts, write me emails, or directly you can call me. Okay, so thank you for watching my videos.